Okay, so this is question 7 from the year May 2025 papers 2 CR, and this basically is the last question of this paper. So without wasting any more time, let's just solve this down. Okay, so it says that this question is about an alcohol, ethanol, C2H5OH, okay, that can be used as a fuel, okay. Ethanol can be produced by the fermentation of glucose. Okay. Name the substance that is added that can cause the fermentation of glucose solution. Yeast. Okay. Yeast is needed for the fermentation. Okay. Yeast. YEA is the yeast. Okay. What is the suitable temperature for this reaction? The temperature that is going to be most suitable for this reaction is going to be 30 degrees Celsius, right? Because temperature above that would basically kill the yeast and denature its enzyme. Okay. And as a result, glucose would not be fermented. Okay. Since yeast is a microorganism and it basically has these enzymes. So temperatures above 30 degrees Celsius would cause the enzymes inside the yeast to be denatured. Okay. So yeah, so explain why fermentation is done in the absence of air. This is because in the presence of air, aerobic respiration would take place, right? We basically do not want this. Okay? Oxygen, oxygen in the air would basically react with ethanol to form ethanoic acid. Okay? So we basically do not want this, right? So we want to ensure that only anaerobic respiration takes place. Okay? So yeah, oxygen in the air will react with the ethanol and form ethanoic acid. Will react with ethanol and lead to the production of ethanoic acid and lead to the production of ethanoic acid. Ethanoic acid, right? Hence, we want to ensure that anaerobic conditions are maintained, absence of oxygen. This is the equation for the combustion of ethanol. Okay, it produces carbon dioxide and water. The equation shows the displayed formula for the reactants and the product. Okay, displayed formula of all of the compounds are shown. Now, the data shows some bond energies. Okay, so calculate the enthalpy change delta H. Show that the enthalpy, molar enthalpy change of the reaction is approximately this. Okay, so you have to basically show. You have to show that delta H is this. So what do we know? Del H equals to BB minus BM, right? Del H, del H equals to bond breaking BB minus BM, bond breaking minus bond making. This is the formula of what? Del H, right? Bond making. Bond making Ki Ng. Now let's just figure out the amount of energy needed to break the bonds, okay? So what are the bonds that are being broken over here? So we basically have this CH bond that has been broken. Okay, so how many bonds of CH are there? 1, 2, 3, 4, 5. Right? So 5 CH. So let's just make a table for bond breaking. Bond breaking. Bond breaking, right? So 5 times the amount of energy needed to break the CH bond, that is 414. 5 times 414 plus CO bond is being broken, 1 plus CO That is 358 plus 358, 358 plus OH is broken as well. Okay, so this bond is being broken, OH. So how many OH? OH is 463. 463. 463. Now this is in the end. We have to basically see the bond that is being broken. Oxygen, double one, one, two, three. Three bonds of oxygen are being broken, right? Three bonds. These three bonds of oxygen are being broken. So three bonds, three bonds, three bonds. Oxygen is 498, right? Plus 3 times 498 plus 3 times 498. Now we use your calculator, find the value that is needed to break the bonds. Okay, so 346. Use the calculator and find me the value of it. Just a moment. 5 times 414 plus 358 plus 463 plus 3 times 498. So this is coming as just a moment. 5 times 414. CH is 414, right? So 1, 2, 3, 4, 5, right? So 5 times 414 plus CO is what? CO is 358 plus OH1, which is 463 plus oxygen, right? Oxygen double bond is what? 190, right? So how many bonds of oxygen? 1, 2, 3 bonds, right? So this is coming as 4385. 4385, right? 4385. 4385, and the unit is what? And the unit is kilojoule, right? So 4385. Well, let's just not write the unit. Okay, 43, this. Okay, now this was for bond breaking, right? Now let's just calculate the one for bond making. Bond making. Okay, so carbon oxygen, how many bond? 1, 2, 3, 4, right? 4 CO bond, CO 804, right? Goes to 4 times 804 plus 4 times 804 plus OH, right? 1, 2, 3, 4, 5, 6, right? 6 times OH, 6 times 463 plus 6 times 4, 463, right? So this is coming as 4 times 804 plus 6 times 463. This is coming as 5994. 5994, right? So therefore del H is what? Therefore del H BB minus BM, right? So bond breaking is what? 4385. 4385 minus bond making. Bond making is what? 5994. 5994, right? So this is coming as 4385 minus 5994. So this is coming as minus I feel like I made some sort of a mistake. It's minus 1300 kilojoule per mole. Okay, so just a moment. Just a moment. I feel like I made some sort of a mistake while calculating the values up on breaking. CH, how many bond of CH have been broken? Oh, wait, hold on. I missed this bond, right? So I missed this bond, okay? So yeah, carbon-carbon bond. This is why you basically have to draw this, okay? You basically have to cross this out, right? So yeah, carbon, carbon bond. Plus carbon, carbon is what? Carbon, carbon is 346. 346. So what is this coming as? 5 times 414 plus 358 plus 463 plus 3 times 498 plus 346. So this is coming as 4731 kilojoule. 4731. Over here we have it. 4731 would be over here. 4731 minus that minus 5994. So this is coming as minus 1263. Do not forget the unit, that is kilojoule per mole. Hence, this is approximately around 1300, right? So the answer is over here shown. Always remember that, always remember, always remember that the unit of daily H is minus kilojoule per mole. You always have to remember this, okay? So yeah, moving on to the next part. It says that complete the energy level diagram for the reaction between these and these. Okay, so del H is what? Del H is negative, right? So this represents that the energy that the reaction is what? Exo, right? Exothermic. Okay, so this should be your products over here. This should be the reactants. Sorry, this should be the reactants, and over here should be the products. Now fill this up. Ethanol plus oxygen, C2H5OH, C2H5OH reacting with 3 oxygen. Leads to the formation of 2 moles of carbon dioxide plus 3 moles of water, H2O. Now for how many mark is this? 3, okay. Now okay, now this is complete the energy for the reaction between these energy level, not profile diagram. Just a moment. Okay, now for this delta H, do you need to show this? Let me just check something here. The reaction is in red, so it should be like this. Now, you basically do not need to show these because they haven't explicitly asked for us to show that. Let me just check again with the mic scheme once more. You basically need to show that, right? You basically do not need to show that. But if you want, you could show something like this as well. So this represents the value. This over here represents the value of del H, delta H. I mean, this is a good practice. Delta H, that is minus 1263. I mean, in your mark scheme, they haven't mentioned about this, but yeah, this is a good practice. Okay, moving on. One more question. Few more question. Explain in terms of bond broken why this reaction is exothermic. Amount of energy needed. Amount of energy. More energy. Let's just see. Bond breaking, bond making. So more energy is given out during bond formation or bond making. Then that is then it is needed to break the bonds. Okay, and hence the reaction is exothermic, right? So yeah, more energy. more energy is given out is more energy is given out when the bonds are made when the bonds are made when the bonds are made then it is taken in when the bonds are broken, then it is taken in when the bonds are broken, right? And hence the reaction is exothermic. Hence the reaction is exothermic. Hence the reaction is exothermic. Okay, everyone. So yeah, we are basically done with this. Take a reading at this. Okay, so moving on to the last part of the question. Second last part. Oh, no, the last part. Okay. C1. Okay. So basically, okay, C1. Ethanol reacts with A to produce the ester B and the compound C. This is the question for the reaction. Okay, so ester is being produced. What is that? It means that alcohol reacting with a carboxylic acid leads to the formation of this ester. Okay, now this basically is the alcohol. Now this is the ester bond, right? Let's just break the ester bond down. This is the part from the alcohol and this is the part from the acid. So ethanoic acid is reacting with this alcohol ethanol to form this compound, okay? And compound C, which is water. Here, so let's just draw this. What is it? Draw the discrete formula of this, okay? So of compound A. So you have to draw the one for ethanoic acid, right? Easy. So C bonded to C, and over here we have hydrogen, hydrogen, hydrogen. You have COO, O, H, COO, OH, hydrogen, hydrogen, hydrogen. Okay. So this is a shorthand formula, right? So anything before the double bond is for acid, and from anything after this is going to be for alcohol. Okay. This is the shorthand method that I use. Okay. And water. Oxygen, water, water. Okay. Done. Now the name of ester B, right? So for naming ester, you have to use this format: alkyl, alkanoid. Okay, alcohol part, acid part. So this is gonna be ethanol and ethanoic acid, ethyl ethanoid. Okay, ethyl ethanoid. Ethyl ethanoid. Ethyl ethanoid. Ethyl ethanoid. So everyone, yeah, that brings us to the end of this paper. If you found our video to be helpful, then make sure to like, comment, and subscribe. Have a great day. See you.